Good morning, students. Today we are going to solve question number 17. Find the shortest distance between the lines whose vector equations are r vector equals to 1 minus t I k plus t minus 2 j k plus 3 minus 2t multiplied by k k f, and equation of the second line is r vector equals to s plus 1 I k plus 2s minus 1 j k minus 2 times of s plus 1 k k. So main taraga nangi I k j k k k pireko. Question number 17. First write the given equations. Given equations in san itosiko. R vector 1 minus t I k plus t minus 2 j k plus 3 minus 2 t k k 5 ko. Sida t yaudaba haina khaidoksiko. T yaudabase I cap tarani. Second case the t yaudabase minus 2 j cap, and the third tagi t yaudabase 3 k cap plus nangi t yaubasingse common lauthoena khaladi I gi coefficient se minus 1 I cap. Second gi the t gi coefficient se plus 1 j cap. Third the t gi coefficient se minus 2 k cap tare ko. Nangi equation of the line se standard form the thame. Standard form means a vector equals to lambda times of m vector haibadu thame. Sina position vector of a point on the line haiba. Sina kai haiba direction of the vector haibaduni ko. Any vector which is parallel to the given line. Equation of the second line is s plus 1 I cap plus 2s minus 1 j cap minus 2s plus 1 k cap ne. Do the s plus 1 multiplied by I, s I cap s I cap plus I cap later ko. Then this 2s minus 1 multiplied by j. So mine toro kona separate toro so I got 2s j cap minus j cap, and this minus 2s plus 1 k cap minus amayawe 2s plus 1 the minus na loy multiply toro. Minus 2s k cap minus k cap separate tore. Then nangi I yauba I cap j cap k cap s yauda basing si grouping semo I cap minus j cap minus k cap plus s lere ko. Dugas the lag to say I cap s yauba se 2 times of j minus 2 times of k cap. Sine equation 1 is in equation 2 tare ko. Nangi line of the equation sing se magi general form do loi ito air. Then we have a1 vectors. A1 vector I cap minus 2j plus 3k, and this b1 vector is equal to minus I cap plus j cap minus 2k. A2 vector, position vector of any point on the line L2, I cap minus j cap minus k, and the direction of the line L2 is given by the vector b2 vector. Components are I cap plus 2 times of j minus 2k. So main tawraga akhona a1 a2 b1 b2 ire ko. Since the distance of the two skew lines is given by the formula d is equal to modulus a2 minus a1 dot b1 cross b2 divided by the magnitude of b1 and b2. Sin a p give formula say, then we need to find the value of expression a2 vector minus a1. Find the difference of a2 and a1. A2 dagi a1 khaidoksiko 1 minus 1 0 I cap minus 1 minus plus 2 minus 1 j cap tareko minus k minus 3 minus 1 minus 3 is equal to minus 4 k cap si phange. Then find the cross product of b1 and b2. b1 ga b2 ga gi cross product loro. Cross product of two vectors b1 and b2 is given by the expansion of the determinant, whose elements are I cap, j cap, k cap. Then write the components of b1. b1 ki components है minus 1, 1 and minus 2. Stay ireko. Then write the components of b2. 1, 2 and minus 2. Ito expanding this determinant along first row. I cap. First row first column ka 1 into minus 2 plus minus 2 into 2 minus plus tareko minus j cap. Find the determinant obtained by deleting first row and third column. First row and second column. Minus 1 into minus 2 plus minus 1 into 1 minus 2 minus plus or k cap. First row ka third ka di minus 1 into 2 minus 2 1 into 1 minus 1. Expand over lore ko minus 2 plus 4 plus 2 times of I cap 2 2 minus 4 j cap minus 2 plus minus 1 minus 3 k cap. Aduna b1 cross b2 hairagadi the vector ram phangi ko. Hause khona pudok tu se kaino distance d the sigi value myam se half se ko a2 minus a1 b1 cross b2 half se le. Distance d is given by haraga a2 minus a1. 0 I cap plus j cap minus 4k cap and b1 cross b2 2 I cap minus 4j minus 3k. Then find the magnitude of these vectors. Magnitude hota reko. Scalar product of these two vectors is equal to sum of product of corresponding elements. 2 into 0, 0, minus 4 into plus 1, minus 4, minus 3 into minus 4, minus minus plus divided by the modulus of 2 I cap minus 4j minus 3k. Modulus means magnitude haibani. Magnitude of any vector is given by root over x component square, y component square, z component square. The minus 4 plus 12 I tare and 4 16 9 cd 29 tare ko. So I pangaga nangi chi root 29 se rationalize tauthok haragadi we should multiply denominator and numerator by root 29. 8 root 29 by 29 units, which is the distance between the two given skew lines. Skew lines ani to give distance tare ko. Next question, extra question. Find the shortest distance between the following pair of the lines. Pair of the sigi lines ani sigi kai puthok seva. Distance puthokadaba ko 2018 the 4 marks ta hangba question. Equation of the lines are r vector equals to I cap plus 2j cap plus 3k plus lambda 2I cap plus 3j plus 4k, and the equation of the second line is 2I cap plus 4j plus 5k mu 4I cap plus 6j cap plus 8k, and these are the equations of two given lines. Solution. First write the equations of the line. Equation 1, equation 2 ireko. Second equation se rewrite away 4I cap 6j cap 8 times of k sa 2 na divide away 2 common lagthoadi 2 times of mu 2I cap plus 3j cap plus 4 times of k. Sumaina multiply tawgibadagidi line ani sigi direction piriba vector se chap manare ko, and we replace this 2 mu constant by mu 1 atopa constant amna represent tawre ko. Adudi nangi piriba line ani se kayure direction manaragadi the two lines are parallel tare ko. Parallel ki formula sijina tare. Then we have first ki sina line 1 ni ko. This is the equation of line 1 and this is the equation of line 2. Line 1 and line 2. Line 1 the lay any point nama iro I cap plus 2j cap plus 3k, and the direction of these two lines is given by the vector b vector is equal to 2I cap plus 3j cap plus 4k cap sitare ko. Then a2 vector, position vector of any point on the line L2 is 2I cap plus 4j cap plus 5 times of k. Sumaina koina a1 a2 b ire ko. Si ito aba matungda the distance between the two parallel lines ki formula pantare. The distance between the two parallel lines is given by kainapi d is equal to a2 minus a1 cross product of b vector divided by the magnitude of b sina b ko. Jodi ko na a2 minus a1 hana putose. A2 minus a1 kana subtract tawrani. A2 dagi a1 subtract tawse ko. A2 minus a1 2 minus 1 1 tare ko. Mathangda 4 minus 2 2 times of j, and the 5 minus 3 is equal to 2 times of k. Hausi ko na kay value puto a2 minus a1. Hausi nang a2 minus a1 si puthokre ko. Si puthoba matungda find the magnitude of b. Magnitude of b se root over nangi b ki component se 2I cap plus 3j cap plus 4 times of k ni ko. X component 2, y component 3, and the z component is 4. 2 square 4, 3 square 9, 4 square is equal to 16, and their sum is equal to root over 29. This is the magnitude of b vector. Then the a2 minus a1 cross b, cross product lausiko. Find the cross product of difference of a2 and a1 and b cross. The cross product of any two vectors in terms of their component is given by the expansion of determinant whose elements are I cap, j cap, k cap. Then write the components of a2 minus a1. A2 minus a1 the 1 2 2 si ko. Then write the components of b. B ki components se kaino 2 3 and 4 sini si ire. Expand to expand to rakana 2I cap plus 0 j cap minus k cap have a vector phangi ko. Sigi vectors se puthokpadagi di sigi vectors ki component naam se distance d dab se. By substituting these vectors in the given expression d, D is given by 2I cap plus 0 j cap minus k cap divided by the magnitude of B. Then find the magnitude of this vector. X component 2, Y component 0, and Z component is equal to minus 1 lereko. 2 square 4, 0 square is equal to 0, and minus 1 square is equal to plus 1 divided by root over 29. 4 plus 1 root 5 by root 29. It will be expressed as root over 5 by 29 units. This is the distance between the two parallel lines. Nangi ngasai pigiba parallel lines tani dugi distance se sigi formula se use tawni ka D is equal to A2 minus A1 cross product of B vector divided by magnitude of B, where A1 is the position vector of any point on the line L1 and A2 is the position vector of any point on the line 2 and B is the direction of the given two lines. Magi direction do oigada. Next topic, plane. Plane haise kaino define tarasika. A plane is a surface such that for any 2 points A and B on it, the whole line segment AB lies on it. Plane hai taragadi nang na any sige white paper sinina khalas yare ko. Stagi nang na point ani khalo. Point A haiba maga B haiba maga C khanba matamda. Sumaina point A B se join tawase. All the line segment between the 2 points A and B, all the points on the line segment AB lies on the plane haiba. Nangi point A M later B M later gadi. The whole line segment has whole line segment is the point मैम लई दोइनी को point मैम से line to the dum leiba oiragadi kai kaure nangi surface से plane kau दोइनी को si plane की definition से important ni or kai haraga suyai every point on the line segment AB lies on the surface है nangi point ani lauraba A haibamga B haibamga lauba matamda AB join tawrakanda sigi line segment AB से plane to the dum leiragadi nangi surface se plane kaureko. Then we are going to derive the equation of a plane. Equation of a plane kamaina derive tawni se tamseko. A plane is determined uniquely if any one of the following is known. Case kya phange? Case ahom se theorem 1, theorem 2, 3 and tamdoini ko. Number 1, it passes through a point and is perpendicular to a given direction. Mase point nama power ga chatlaba aduga nangi vector amada perpendicular taraba. Second case the normal to the plane nangi plane to the normal oiba any vector ampiraba ko and its distance from the origin is given. That is the equation of the plane in normal form. Equation of the plane in normal form hai taragadi nangi plane sida normal oiba vector am leiraba aduga nangi plane se origin dagi kyam lapi have a distance to piragadi sina kai kaure equation of the plane in normal form kawe ko. Number 3, it passes through the three given non-collinear points. It passes through the three given non-collinear. Non-collinear means kai hare nangi point ahum se line amada leitaba. If 2 or more points are said to be collinear if they lie on the straight line. Straight line am the labor points se collinear kawe. Adu nangi plane sina power ga set kadaba se non-collinear oiba ko. Straight line am the leitaba oi kadaba. Aduna hose akoina ahanba theorem sa yengsi ko. First theorem, derive the equation of a plane passing through a given point. Point nama power ga set ko and perpendicular to a given vector. Nanga plane ama derive tawgadaba point ama power ga chatpa vector amada perpendicular taba ko. 1 point form kawe. This form of plane is called 1 point form of equation of a plane. 1 point form hai disi formula se itare ko. First akoina sigi plane ama khalasi ko. Sigi plane sina point A se power ga chatlini aduga ma se kanada perpendicular tare sigi n vector sida. Let A vector be the position vector of a point A on the plane and R be any point on the plane with position vector R vector. Nang si A vector se position vector of any point A ni on the plane to the label ko. R sine any arbitrary point ni. R be any arbitrary point on the plane with position vector R vector, which implies that AR vector lies on the plane and AR vector will be equal to R vector minus A. Definition of plane gi matungina point A, point B lairagadi AB line segment se plane du da dum laini ko. Adugi definition du gi matungina point A haraga R haibam ga laitaragadi AR line segment se lies on the plane and AR vector AR vector is given by position vector of R minus position vector of A. Position vector of R is R vector and position vector of A is small a vector. Let n vector be a vector normal to the plane. Plane to the normal over any vector amane. In particular, nang si plane ni ko. Plane si the line segment me am yek pasa. Sigi n vectors tatum perpendicular ta neba. Maram kay gino hard this n vector is perpendicular to Canada. Nangi plane si the perpendicular ta idana. Then AR vector lies on the plane and AR vector is equal to R vector minus A tagre and N vector be a vector normal to the plane harekwa. In particular, AR vector and N vector will be perpendicular. Example oina nangi N na layrise. Aina pariba pencil se. Si nangi boy si the perpendicular taidana. Adudi nangi boy si the yek pa any line segment kuding magta. Nangi sigi pencil sina perpendicular dum taani. Adugi case to the sigi N vector sina AR haibas the perpendicular tahale ko. Perpendicular tahale adudi AR vector ge N ge perpendicular taragadi. Scalar products de kaitani 0 tabam thoe ko. AR vector means position vector of R minus position vector of A dot N vector equals to 0. See equation 1 or which is the vector equation of a plane. Vector equation of the plane which is the vector equation of the plane. Nangi plane dugi vector equation ni. Second equation da khoi na kai daw ni Cartesian form derive daw. Sina vector de express daw was a vector form ni. Mathang da Cartesian de express daw se ko. Cartesian haidi xyz de express daw was. Let a vector A is a given point ni ko. Given the x1, y1, z1 represent daw gadaw. Let a vector equals to x1 ik plus y1 jk plus z1 k. Then R vector. R se any unknown hoigi ko. Unknown di xyz na represent daw gani. xi cap yj cap plus zk cap. N vector. N vector haitar the direction ratios ta doini. Direction ratios are denoted by ai cap abc natra. Component from the era the ai cap plus bj cap plus ck cap. Sumai thoe ko. Then the equation R vector minus a vector dot N vector equals to 0 becomes. Se kaida olakani. R ga A ga khaidoknar. R ga A ga khaidoknar di x minus x1 ik plus y minus y1 jk plus z minus z1 k cap tare ko dot. Mathang the N vector. Write the components of N. aik plus bjk plus ck cap equals to 0 and find anisigi dot product lausiko. Dot product log haitar the x component multiplied by x, y component multiplied by y, and the z component multiplied by z. X minus x1a, y minus y1b, z minus z1c equals to 0. A na mamang tange, b na mamang tange, c na mamang tange, 0 saleko, which is the Cartesian equation of the plane. Sina vector equation ni sina kaino Cartesian. Vector haidi vector de expressed was the vector form. Cartesian or agada xyz expressed over duna equation of the plane in 1 point form gi importance se kaino nangi AR se kanada perpendicular oiba n vectors si khanga diare ko AR vector is perpendicular to n or agadi AR vector dot n se 0 chatkani maram kai gino angle between AR and n vectors and 90 tarani and cos 90 ki value di 0. Then write the position vector of AR. Position vector of R minus position vector of A dot N vector equals to 0. Sina equation kya thare? 1 thare ko. Sina nangi vector equation ni aduga second case sina kaino Cartesian equation. Next number 2 theorem. Equation of the plane in normal form. Normal form the label ko. Normal form se kamaina haikani haitar de. Here we are going to derive the equation of a plane at a distance d from the origin and perpendicular to a unit vector and k5. Nang na hujik derive to sigi plane sine. Sigi plane se origin dagi kyam lapi haradi distance t lape aduga mase kanada perpendicular oire n cap ta n vector oibe ade n cap to oigadaba ko. Let OA be the perpendicular drawn from origin on the plane. O dagina A bause aina distance laurabanina ma perpendicular tane. This OA is perpendicular to the plane. Plane the perpendicular. Sumaina mathak the yung khalakpa mongs te laktuini ko. Aduna O dagina A bause kya sangani D changi ko. And koina kaidore n cap haibase kaino n cap BA unit vector normal to kanada normal ohele plane sida. Sina OA vector ni ko sina n cap haiba. Dudi nangi n cap siga OA siga kai tani ani se parallel oirakadaba ko sumaina pulap yung minarakadoinina ani simu kai tarani parallel oigadaba. Duna sigi OA cap a unit vector acting along this OA vector is given by OA vector divided by magnitude of OA n cap. Since OA cap is parallel to n cap, so this OA cap is to be replaced by n cap is equal to OA vector divided by distance d. O dagina A bause kyam laki d lapi ko. By cross multiplication, position vector of A is equal to d into n cap, where d is the distance of the plane from the origin. D se kaino origin dagi nangi plane se kyam lapi haibaduni ko. Dugi n cap haibasina nangi plane se da perpendicular or unit vector duni. Let capital R be any point on the plane with position vector R. Sigi R si any arbitrary point ne. Aduga magi position vector se R lore ko. Dudi masagi theorem number 1 gi matungina equation of the plane passing through point kana phawba passing through point A n normal to n cap si palasu yare natraga kai harasu yare nangi AR haiba vector se kanaga perpendicular tani OA siga perpendicular taroidra taiko. Therefore this AR vector is perpendicular to OA. AR the position vector of AR ga OA ga perpendicular oiradi ani sigi dot product se kya tabam thoe AR vector dot OA vector equals to 0 saleko. Then write the position vector of AR. Position vector of R minus position vector of OA lereko dot OA se ngasai kaiga managre dn cap haibase tagre ko dn cap is equal to 0. OR position vector of R is R vector minus D and OA. Position vector of OA is dn cap dot dn cap is equal to 0. Since D is a scalar, distance size is scalar in a divide of ko. We divide both sides of the equation by D and we get this remaining equation. R vector minus D n cap dot n cap is equal to 0. Sila dot product ki distributive law pantare ko. R vector minus D n cap se n cap siga dot product loba. R vector dot n cap minus D lere ko. N cap dot n cap is equal to 0. R vector dot n cap leijare aduga mathangda kai lakani R vector dot n cap minus D n cap dot n cap sapmanaba vector ngatani ko sidi sapmanaba vector gi dot product ki formula ire magnitude of n cap into cos 0. Since n cap are equal vectors and their angle between is 0. Angle between them will be 0 lore. The cos 0 nagi right di 0 dum leiri ko. R vector dot n cap minus D. N cap si 1 tare cos 0 si 1 tare ko equals to 0. R vector dot n cap is equal to D. D transpose togre equation 1 tare, which is the equation of the plane in the vector form. Vector form set equation of the normal form oidoini ko. Normal form ni R vector sina kaino position vector of any point on the plane. N cap haibasina nangi plane to the normal taba unit vector amani ko. Distance D is the distance of the plane from the origin and sinang khang tare ko. Next, we have to derive the Cartesian equation of the plane in normal form. Cartesian da kamain tawgani nangis the changis the R vector gi n cap ka D constant ni maji sillaroi ko. Let R vector equals to xi cap plus yj cap plus zk cap. N cap is equal to li cap plus mj cap plus nk cap. Ngasagi n vector haradi direction ratios ne n cap haradi direction cosines ne ko. N cap components of any unit vectors are called direction cosines, and direction cosines are denoted by L, M, and losile. Then the equation r vector dot n cap equals to d becomes kaijasen story. Write the components of r vector, write the components of n cap is equal to d, and find the scalar product of these two vectors. Lx, m into y, my, n into z is equal to nz is equal to d, which is the equation of the plane in Cartesian form. Aduna nangi equation of the plane derived tawbagi formula se kya phange? Ani phange ko. Ahanbada equation of the plane passing through a point and normal to a vector. Second na kai haiba? Nangi distance of the plane from the normal sina d haina piraba, and nangi plane sida normal oiba unit vector haiba ma piraga d khona equation of the plane se derived tawba ngammi ko. For today, let's end here.